Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Today I've got another guitar amplifier sitting on top of the desk here. I don't want to turn this into the guitar amplifier channel, but it's basically all I can find that's interesting to look at. Bit of a cobweb there. Before anyone asks what that murmur in the background is, I've got a small desk fan going in the background because it's hot as a mother in here. Anyway, I paid $6.60, that's 10% GST, that's why the price is weird. From the Glenorchy Tip Shop, parts only, and of course they have cut the bloody cord off, so it's no way known whether this is electrically safe. It makes it harder to test what's actually wrong with it. Now there's a good look at the front panel. We've got the overdrive channel here, which is the gain depth, which I'm not sure, well, yeah, that's how much gain it has, and overdrive master volume, plus the defeat switch clean overdrive. It's the KS10 model, and it says series micro lead. Righto, and this one actually has a serial number on it. Nice. And it runs at about 0.25 or 250 milliamps on the input side at 240 volts and is 24 VA. That's nice to know. Warning: to reduce the risk of fire or electrical shock, do not expose this appliance to rain or moisture. Replace with same type fuse and rating, not that I see a fuse. And then it's in a different language. So I don't know if I mentioned this was a Samick, by the way, but you would have seen that on the front. Yeah, there's no fuse that I can see here anywhere. It's not on the bottom either, but that's alright. Whether I'm going to worry about one or not is another story, but I don't know what's wrong with this, if anything's wrong with it. So what I'm going to do with this one, like I did with the previous one, that Scorpion, is I'm going to just take the chassis out of the unit and disconnect the driver and do some tests on the chassis out of the cabinet, and that way I don't destroy the loudspeaker any further if it hasn't already been destroyed, and see if there's any carnage on the inside, like something's completely blown up. So with this one, cobwebs and all, luckily this actually just unplugs. It's not actually soldered to the driver. So that makes it easier to disconnect, so that's now free of the driver. I'm going to remove the 4 screws on the top of the cabinet to undo the chassis. I'll find something to put the screws in. These KFC potato and gravy containers are actually quite a handy thing. Cabinet needs a little bit of a clean, as usual. Nothing new there. So all these 4 screws come out and put to the side, and I'll see how this comes out. Does it come out backwards or does it come out forwards? It feels like it comes out forwards, but it can't come out forwards. Okay, so you've got to get the angle of your dangle right, so it angles down and comes out backwards. Nice. So we can now get the cabinet out of the way. Right, so here's a good look at the internals. It needs a bit of a clean, but I don't see anything obvious. They're using a KA3403, which I believe that's the correct number. There's that number down there. I believe that's a quad channel op amp, which would make sense because you've got the overdrive side op amps that would need to be there to give the distortion. There's a couple of diodes here as well, which would be forming part of that, plus an op amp for the clean side, so it's got some form of amplification before the power amp, and I'm not sure whether the tone control stack at the front here is passive or active. However, over the other side of the PCB here, they've got a bunch of unpopulated components, so another op amp would have gone here, and I believe that might have been for an active back handle bass treble mid-range circuit. And there's also a place up here for an extra variable resistor, a 10k pot, logarithmic, an extra hole on the front which you can't really see, which is there for another socket. So it might have had like an effects send or return at some point on a different variation. I'm not 100% sure, but there's no volume control for the headphone socket, which is over here. So I'm not seeing anything that's blown up. Out of interest, what output IC are they using? They are using a TDA 2030, which may be a 20 watt amplifier IC, it could be a 15 watt one. I'm just going to quickly look that up. Right, according to the data sheet, it is a 14 watt hi-fi audio amplifier. I was close when I said 15 watt. And according to this equivalent schematic down here, we've got some protection flyback diodes between the power supply rails and the output. And it does almost look like it's a direct drop-in replacement for a LM1875. The pinout is the same. Yeah, it looks like it would actually be compatible with the same IC as an LM1875, which is nice. Anyway, we don't need to know too much more about that. It's pretty much basic op-amp power amplifier 101. There's nothing special about it. The one in the unit would be laid out pretty much the same as this schematic here. And just for reference, the KA3403 is definitely a quad operational amplifier. There's its pinout, which is pretty much a standard pinout for a 14 pin dip. So yeah, it's nothing special about that either. And there's the equivalent schematic there for people who really care. I don't. It's pretty much like any bog standard op-amp, nothing really special. However, we're no closer to fixing this, but I did find that there is a fuse here, and I can't tell if it's blown because without taking it out. So I'm going to have to measure it and see if it is indeed blown. So on continuity, nope, the fuse is not blown, so that's good. Alright, so what I'm going to do is I'm going to do what I did with the Scorpion, is I'm going to test for continuity from the power cord to the transformer's primary and check the secondary. Now the secondary is this plug here. So that's easier to test by just getting rid of this cable tie here. Maybe. So, throw that in the bin. I'll put a new one on later and unplugging the connector. So, bring the meter in. Light over there. I'll put this back to resistance. Don't know how well you can see that, it's a bit over bright, but that's alright. So across the two red wires we have absolutely bugger all, no resistance. Maybe it's not making contact. There we go. We have about 2.5 ohms. So yeah, that's not too bad. So across centre to one of the outer windings we should have about half that resistance, if I can get a good connection on there. We have 1.2 roughly, 1.25, something like that. So it is roughly half of the resistance. So I know that the secondary of the transformer is fine, and I'll just measure from the centre to the other outer pin, and we should have roughly the same resistance of about 1.2 if I can get a connection. 1.3. Yeah, roughly the same. So far so good. So I can put the meter aside, and I seem to have some rat shit on the desk. I don't know why that's there. It probably came out of the cabinet, so that goes in the bin. So I plugged that back into the main PCB before I forget to do so. Now I need to get to the primary winding, and It looks like they're switching the neutral. Where does that go? That goes into the transformer. That is capped off, so that goes nowhere. So this would be a 110 or 120 volt and a 240 volt. So they're not using the blue wire, they're using the black wire. So the black wire is the neutral, and they're switching the neutral rather than the active, which is nasty. Alright, so active comes in to the transformer here, so I'm not worried about it from the line cord. So I'll see if I can get a connection there and a connection out to the switch, which is exposed even though it's supposed to be insulated. I don't have any continuity there. And the switch is on, so however on the other side of the switch, which is the switched portion, the output to the transformer, is 180 ohm. So it appears that that switch is not working. So let me go back into continuity mode and it make it easier. There is no continuity. None whatsoever. So we've got a faulty switch. That's probably all that's wrong with this, is a faulty power switch. Now, the astute viewer may be asking themselves, well, how am I going to fix that without replacing the switch? Well, with great difficulty. I need to actually get the switch out of the unit. It's got to come out anyway. Now, I don't know if the switch will actually come apart. There we go. So that's out. Yeah, it doesn't look like I'm going to be able to successfully get into that switch at all. It doesn't come apart, which is a shame. So this is a 5 amp, 6 amp, 250 volt AC switch. I don't know how well you can see that, but it does say down here that it's a 6 amp. I've masticated the plastic a bit. It's a 6 amp, 250 volt. So yeah, that's going to be kind of annoying to change because I'd have to get this heat shrink off of the switch terminal so I can unsolder it and then put new heat shrink on it. And these wires of course are not long enough, but I also have to wire on a new power cord as well. So very, very interesting. That switch has buggered itself. So I'm going to go out on a limb here and say it is definitely because of the arcing over time across the switch. So I know we haven't got a short on the transformer or anything, but we've got absolutely no continuity across the terminals of the switch. So yeah, that's going to have to be replaced. There's no two options about this. I don't know how well that heat shrink's going to come off the pins. I'm just going to bend my multimeter probe doing that. Better stop doing that. Use a flat blade screwdriver, that's what it was designed for. Yeah, here we go. That's all I needed to do is just to break away the heat shrink away from the terminals so I can unsolder the switch. Okay. So at least this actually does have inline fuse protection, which is nice. Right, I still believe JCar sell these type of switches, so I'm okay there. So I'll just unsolder the wires as I can. It's a little bit awkward trying to do it like this. They've actually put it through the hole. There we go, that's out. That leads a bit longer. So we'll just jiggle that around till it comes out. Okay, that switch is now out of the unit. I'll just double verify I'm in diode mode instead of continuity, which is stupid, but anyway. Well, that's interesting. Now we have continuity across the switch. We didn't before. And with it off, we definitely don't have continuity. So although it's not very great, because I was touching the probes together. No, we do actually have continuity. It's just not very good. Okay, hang on. Let me get some test leads onto that switch so I can actually hook the multimeter probes up to it a little easier. I hope no one's actually bored yet with just me fiddling with the switch, but this has to be done in order to make sure that I'm on the right track, because I reckon we've got a dicey connection. It seems to be the center lead. When I move the center lead, the continuity goes away. Push on it, it comes back. Yeah, see, it's not always going to make continuity when you turn it on. So either this pin internally is loose from its mounting position, or the rocker pin that comes into contact with the two terminals here is bent or something like that. It's stupid internally. Yeah, because it doesn't make very good continuity until I push on the actual terminal. So yeah, I'm going to say that this switch is absolutely and utterly knackered. So that's going to have to be replaced before we can even go any further. And a short time later, well, half an hour later, I've actually gone to JCar and I've got the switch that I require. It's exactly the same, only 2-pin jobby. And traffic was a bitch. And speaking of bitch, getting this new power cord, which is only about $7, into where it came out of is going to be challenging, to say the least. But it's doable. So first, we're going to just check that this switch actually works properly. So currently it is set to the off position, so if I put my leads on, and we got no continuity, no problems. Perfect. Right, so the first job is to put the cable into the unit. I'm going to wire it exactly the same way they did, which you shouldn't do, which is wire the neutral to the switch and out to the transformer, which is not the correct way to do it. But there's nowhere else here to actually wire the neutral to, unless I join it to, well, the neutral wire here and, you know, heat shrink it, and it's just going to look just as ugly. So we'll stick with how they've done it. So I need to untangle this mess, and I need the clampulator. So the easiest way I'm going to do this is to work out how long I need the cable to be to go to the front. Is I put the cable in first, and I want probably a bit sticking out the front to make it easier soldering to the switch. I might be able to salvage that, I don't know yet. So I want them about that long. So we have about 80 millimeters sticking out from the back, so I'll put the clamp-a-lator back on around about there somewhere. Grab a pair of pliers and I'll squeeze the shit out of this. Get it started in the hole at least, and then hopefully with a little bit of coaxing, there we go, it's in. Nice. That wasn't so difficult. So now I'll just re-establish the ground connection. Now it had the shape-proof washer up against the chassis for whatever reason, and no washer on top, but that really worked. Actually, I'll put it on the end of my screwdriver first. That'll make it easier. Through the eyelet, through the washer, and screw it into the hole, pointing it off that way somewhere, and I'll cable tie this all up nice and neat later. But for now, we've got to do some wiring. Now, I will stress that if you are unsure of what you're doing around AC mains, don't do it. There's nothing worse than killing yourself, and being this close to Christmas, it's not worth killing yourself. So I'm also going to need some heat shrink to go over the end of the switch, so I'll get that all sorted. Alright, I believe this is the right diameter. This is a doesn't tell me, a 5mm to 2.5, so it's a 5mm diameter originally and shrinks down to half its size to 2.5, which will be perfect. And it's yellow, so I'll just cut off a couple of strips of this, and because they've got to go on the wires first before attaching it to the switch, or the wires to the switch. And now I've got to get rid of this piece of heat shrink, which is no longer any good. So I might make this a little bit easier. I'm not going to pass it through the hole. I will just solder it directly to the tab. So I'll put a new piece of heat shrink on. Hopefully that won't break. That is double insulated stuff too, so that's great, as it should be. Find somewhere to put it where it's not going to float around on me. It's still going to float around on me. Whatever. So we'll just re-tin the end of the wire there so it's got fresh solder on it. Makes for a better connection. So that's going to go to the center point there. So I'll just prop the switch there, and I will tin up the connection like so. And before I do something stupid, I'm going to make sure to pass the wire through the hole, and I'm going to attach it to the end of my little handy dandy tool to make it easier to solder. That's about the best I can come up with for that, so it'll have to do. It's alright, I just saw something move outside. It's nothing. Okay, that's soldered on. Hopefully that's not going to break off on me. I might actually leave that connected to there so it makes it easier to do the second wire that's got to come in. Which might prove a little bit more challenging to get through the hole. I could probably tin it first, but then it makes it awkward soldering to it. Like getting it through the hole. Now, as long as all the strands of the wire go through said hole and don't bunch up on the outside, then we're all good. Solder him on there. Touch it up on the back. Now I can remove it from the tool. and I'll try and trim off that excess bit of wire that's hanging around. Make it a little bit cleaner. And then we can pass the heat shrinks up through the hole to the switch like so. I'll get that out of the way. Find my lighter. This is going to be fun, so I might actually do it standing up, because I don't want to burn anything that I'm not supposed to. I just want to shrink the heat shrink, not actually burn anything. That was terrible. Didn't quite go on there, but it will stop from accidental electrocution, or electric shock I should say. Alright, that should be sufficiently heat shrunk. So now I can place that the same way the old one was, with it facing up for on, into the hole. Excellent. So they've used black heat shrink for the active, but I'm just going to use a piece of yellow, it's fine. Makes no difference. It's the colour is not important, it's just its functionality. So that goes on the end of my active wire. Twist the strands together and I'll pass it through the eyelet, which I don't think the hole is going to be big enough. Somehow I doubt the hole is big enough, because it's just going to bunch the strands up on the outside, and that's not what I want. I think I was a bit more successful that time. Right. Solder that one in. Make sure it gets enough solder on it, which it did that time. And let's put some on the back, if I can get in there. There we go. Right, that looks okay to me. I'm going to go with it. Put the heat shrink on, which should start immediately shrinking due to the heat of the terminal. And I missed the terminal. Right, now it's on there. So I need to shrink that down. Might make it easier by popping this fuse out to do it. Alright, so I don't want to melt something like a capacitor. So that's good enough, that's shrunk, and there we have it there. It's now all rewired. Just pop this fuse back in. I'll clean up the mess on the desk, throw this bits of crap out. And we might as well cable tie some things together whilst we're here, because it's all ready to go. So I want to cable tie all of this stuff together to start with. Something like, if I can get it in there, something like something like that is what I was going for. Because once it's back in the cabinet it won't matter. I just need to tidy the wiring up so it's not just floating around. I am not going to cable tie down here where there was an original cable tie, because I reckon that's what put stress on the terminals. causing it to go open over time. So I'll put another cable tie on the back of the cable and the rest of this stuff here, just to hold it nice and still. And there we go there. That's that repair completed. So now we want to do a continuity test from the power plug through to the transformer. So I will stick this on, and it's going to be 160 ohms I think it was, or 180, so I'll just leave it on resistance. Now the switch is currently off, and if I switch it on, we should have 182 ohms. There we go. So whilst it's turned on, we'll check between neutral and earth. No resistance, so that's fine. Between active and earth, bugger all. So that's actually safe to plug in and turn on with no disastrous results. So good, we've got continuity all the way through the unit. So all I need to do now is clean up a bit and put it on a dim bulb and test that it actually turns on. And do a preliminary output test of the power amplifier to see what voltage we've got DC wise there. And then we'll continue on testing with an oscilloscope, and finally the cabinet itself. Alright, now I've got it hooked up to the dim bulb now, the output's not shorted. It's bitey around here, so keep hands well away from the mains wiring. So I'm going to turn the dim bulb on. I've got the desk lamp off so we can see what the dim bulb is doing. I'll turn this on. No activity on the dim bulb, but we have a power indicator LED. That's good. So that means that we've got a reasonably working circuit. So now I'm going to hook up the multimeter on volt DC across the output terminals. Just jam that in there. I'll hold that one in there. Put that where you can see it. Probably there's better. Alright, turn it on. And according to that, we've got absolutely hardly any DC offset, maybe about 1 millivolt. So let's put it into millivolt scale. We have all of about 2.1 millivolt DC offset on the output. That means it's safe to hook up to a load and or the speaker. Excellent. So far, so good. Alright, everything's set up, dummy load, dim bulb still connected for now. The sine wave generator set to 1000 kilohertz and running. Oscilloscope on ×10, so now I'm ready to turn it on and see if we've got an output. The controls are halfway. I see absolutely nothing. That's because the dim bulb's not turned on. Oh, now I see an output, but it looks like crap. And for some reason I've got a output on the blue trace which is not even connected. However, it could be a bad ground, so I'll just reconfigure the ground. Alright, we've got a problem with the lead clean switch here. It's a bit dicky. If I wiggle it, the signal drops out, so I'm going to have to squirt that with some cleaner. But before clipping now, we've got around about 22 volt peak to peak and 7.7 volt RMS. However, yeah, that's only about a dismal 6.6 watts. But it is what it is. Okay, so I'll change my mode to square and we'll check the operation of the active EQ. Bass doesn't appear to be doing anything, but we are clipping, so I will drop the volume right down. Bass control cut, boost is doing something. Mid boost, mid cut is doing something. Treble boost and treble cut is working as expected. So I will put that back into sine wave and I will test the operation of the lead switch, the lead circuit. Now that's not affected by the master control. I'm turning it, it's doing nothing. That's only for the clean level, which is kind of annoying. Yeah, but it does appear to be doing something, but we're only going to be pushing out 3.7 volt maximum RMS, which is not a lot. So it's probably not the best guitar amplifier ever designed, but yeah, I guess it'll do the job. Now I'm going to do this with it still turned on so I can see what's going on. Shouldn't hurt anything. Still seems a bit dicey. So I'll squirt it again. It seems a lot better. I'm wiggling the switch and it's not really reacting with it. Okay, I'm going to say that that is, for all intents and purposes, cleaned and operating correctly. I don't know how I'm going to go getting any cleaner into the pots, so I'm going to leave them alone for now because I don't really need to mess with them. As you can see, the chassis is back into the cabinet, so I'm now ready to test it connected to the speaker. So I'll plug the input lead in. Well, it is actually significantly loud. The clean's louder. Bass is doing something. Mid-range is doing something. And that's doing something, and I'll just test that the headphones out are working. Don't know if this mutes the speaker. Yeah, apparently it does. Yeah, headphones are coming out, working and coming out both channels. That's excellent news. So I don't have to dick around with that. So I guess I'll hook it up to my bass and we'll see what it sounds like. Well, it has to be up significantly loud. It's not the right speaker for bass anyway. That's flat chat. So yeah. Yep. It's not really a full range speaker either. Okay. Okay, I'm going to assume, for all intents and purposes, and that switch seems to be working fine too, that this one is fixed. I'm way out of practice with bass too anyway, so we'll ignore that happened. But anyway, what you shouldn't ignore is, if you enjoyed this video, please go down below, like, comment and subscribe if you haven't done so already. And this is Yashra30 saying, see ya in the next video. And yes, I still got to clean the cabinet on this one. I'll do it later. But anyway, thank you for watching. Have a great day.